Guys, now we are going to start a new topic, isomorphism of a graph. Here it is given an example on that topic. Determine if the following graphs are isomorphic or not. First we will see here that let us take G1 graph and this graph is a G2. Now first of all we check that the number of vertices in this graph is equal to a number of vertices in this graph, and then we will check the number of edges in a G1 is equal to a number of edges in G2. Let us check it. Here in G1 number of vertices are 1, 2, 3, 4, 5, 6, 7 and 8. Here in G1 number of vertices are 8, and let us check in G2 1, 2, 3, 4, 5, 6, 7 and 8. Here it is also number of vertices are 8. Now we will check number of edges in G1 and in G2. Wait a minute, let me erase it. Here number of edges are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Here number of number of edges are 10, and in G2 graph 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Here it is also number of number of edges are 10. Now we will go for the next step, that is here we will take a table like this and we will write all the vertices here and their degree and degree of their adjacent vertices. Let us take an example from here only. Let us take A. Degree of A is wait a minute. Now degree of A is 1, 2 and 3. Therefore we will write here 3. Now degree of adjacent vertices means their adjacent vertices are, wait a minute, let me erase this. Yes, adjacent vertices of A are B and D and E. Now we will check for a B. Here degree of B is 1, 2 and degree of E is 1, 2 and 3. For B it is 2, for E it is 3 and for D it is 2, that is 1, 2. Therefore we will write here vertex degree of adjacent vertices are 3, 2, 2. Now we will go for a B. Similarly we have just find out that degree of B is 2. We will write here as it is. And now degree of adjacent vertices, that is B has its adjacent vertices as A and C. Now we will find their degree, that is A has a degree, we have find it out here 3, right, that is 1, 2 and 3. Now C has also degree 3, that is C is equals to 3. Now we will write here as 3, 3. Similarly if we go for a C, now If we take C as a vertex, it has a degree 3 and its adjacent vertices are D, G and B, where B has a degree 2, D has a degree 1, 2, 2 and G has a degree 1, 2 and 3 is equal to 3. Therefore, here we will write 2 comma 3 comma 2. Now similarly we will find for a D, E, F, G, H and P, Q, R, S, T, U, V, W. We will find for a P and Q here. Forgetting you. Now let us take a P. P has a degree 1, 2, 3. Therefore P is equals to degree 3. Now adjacent vertices are T, S and Q. Wait a minute. Adjacent vertices are T, Q and S. Now we will find their degrees. Q has a degree 1, 2 and 3. Therefore we will write Q is equals to 3. Now S has a degree 1 and 2. S is equals to 2. Now T has a degree 1, 2 and 3. T is equals to 3. Now here we will see 3, 2, 3. That is 3, 3, 2. Now for a Q we will see Q has a degree 1, 2, 3. Therefore Q is equals to 3. We will write that here as 3. And now there are adjacent vertices that Q has adjacent vertices as 1, 2, 3 and degree of adjacent vertices are 1, 2, 3. That is it has a 3 and it has a 1, 2 again 3 and it has 1 and 2. Now 3, 3, 2. That is 2, 3, 3. Here we will check that vertex A has a degree 3 and the degree of adjacent vertices are 3, 2, 2. We will check a similar vertex that has a degree as a 3 and the adjacent vertices has a degree as 3, comma 2, comma 2. First we will check for a P. It has a degree 3 and the degree of adjacent vertices are 3, 3, 2, not 3, comma 2, comma 2. Therefore we will write no, 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 no and no. Here it is 3, 2, 3, 2. That we can say that function of A is equal to W. Now we will check for a next. Here for a B, it has a degree 2 and degree of adjacent vertices are 3, 3. Now let us take same here, which has a degree 2 and degree of adjacent vertices are 3, 3. Not this, not this, not this, not this, not this, not this, not this and not this. Now we will check for a next. Here it is not equal to, that is f of b is not equal to vertex in a G2. Now here similarly, if we see here, it is again given a vertex of a degree 3 and degree of adjacent vertices are 3, 3, 2 and 2. Here again we will find such a vertex that is equal to a degree 3 and adjacent vertices has a degree 3, 2, 2. Now we can't take this as f of a is equal to w. Now we will check for another one which has same degree, where it is gone, which has same degree 3 and has degree of adjacent vertices as 2, 3, 2. Not this, not this, not this, not this, not this. Again, we can't find such a vertex that is equal to a degree 3 and the degree of adjacent vertices are 2, 3, 2. Here we can write from above table, we say that in G1 vertex with a degree 3 having a degree of adjacent vertices are 3, 2, 2 and that does not exist in G2. We can also write that from above table we say that G1 vertex with a degree 2 having degree of adjacent vertices are 3, 3 does not exist in a G2 for B. But here it is only given for a 1, that is degree 3 and 3, 2, 2. But we can also write it as degree 2 having a degree of adjacent vertices are 3, 3 does not exist in a G2 and therefore G1 is not a isomorphic to a G2. And also firstly we check that, wait a minute, let me erase this all. Yes, now firstly we will check that the degree of this vertices in G1 is equal to a G2 and the number of edges in a G1 is equal to a number of edges in G2. If they are not equal, we will say that they are not isomorphic. That's it.